Welcome, wizards. Step into the world of SyntaxWizards, where coding becomes not only doable but also fun and exciting. Our mission is simple: to take you from knowing little about code to building your very first project with confidence. All it takes is the right tools, a bit of guidance, and a spark of curiosity. Today, we're diving into one of the first magical ingredients in the world of coding, variables. Let's go through 4 objectives that we will be covering for this episode. Firstly, introduction to variables, which consists of the definition of variables as well as going deeper. In other words, to explore some real-world applications of how a variable will interact in the code. Secondly, variables in action. Some areas that we will cover will be naming your variables, data types, declaration and initializing, global and local scopes, as well as type conversion. Thirdly, difference between constants and variables. Some areas that we will cover will be constants as well as variables. And last but not least, good practices and common errors. Some areas that we will cover will be meaningful names, check spelling, as well as to use variables. Whether you're a total beginner or you've just started dabbling in code, we'll guide you through the magic of variables and show you how they can unlock a world of coding possibilities. So grab your coding wands and let's get started. Let's start with the first objective, introduction to variables, definition of a variable. So, what is a variable? A variable in programming is a named storage location in memory that holds a value. It allows programmers to store, retrieve, and manipulate data dynamically, making it essential for flexible and maintainable code. Essentially, it is a storage space made to make the code more usable and maintainable. Going deeper. Well, think of a variable as a special storage container in your code. In programming, it's like having a space where you can keep information you'll use later. It might be a number, a word, or even something more complex. You can take this container as a mental reference. Just like you'd use a notebook to jot down reminders, a variable is like a little memory slot where you save valuable info. A memory slot might look something like this. Imagine you're building a game and you want to store the player's score. Well, you'd use a variable to keep track of it as they play. Using variables that can be dynamically updated allows the code to run more efficiently and usable. And each time they gain points, the variable updates automatically. It's as simple as that. Pretty cool, right? Next up, on to our second objective, variables in action, naming your variables. Next, let's talk about naming your variables. Think of your variables as characters in your code. They each have a role to play and they need unique names that tell them apart. Here's the golden rule. Variable names should be clear and easy to understand. For example, if you're tracking a score, call it something meaningful, like player score or game score. Trust me, this will make reading your code so much easier, and you'll thank yourself later. Now, a few tips. Variable names shouldn't have spaces. You can use camel case like player score instead. Also, they can't start with a number, and they can't use special symbols. Keep it simple, and you're good to go. Data types, numbers. So, we know what variables are. But what kind of info can they hold? This brings us to data types, the different kinds of information that variables can store. Think of it like this: just like in a game, you'd have different types of characters, like warriors, wizards, and healers. In programming, we have different data types, numbers, text, and true or false values. Let's break them down. Integers, whole numbers, like 1, 10, or 24. Here's an example of how an integer might look like in code. It starts with the variable type, followed by the variable name and the value. Or floats, numbers with decimals, like 3.14 or 98.6. This is similar to the previous example. However, the only difference is the variable value that changed. Strings, any text, like hello wizards. Strings are basically text data type. In this example, it demonstrates the use of strings in code. And booleans, true or false values, like is game over equal to false. Booleans only have true or false values, so like a choice, or can be used as the state of a function. In this example, you can see the application of the Boolean for the selected choice variable. These types help the program understand how to handle each variable, and as you code, you'll see just how handy they are. Declaration and initializing. Now that we know what variables are and what they can hold, let's cast our first spell, declaring and initializing a variable. Declaring a variable is like telling the computer, hey, I need a space for this data. And initializing is when you actually give it a value. Here's an example. If I write let player score, I've just declared a variable. Now, if I say player score equal to 10, I've initialized it by setting it to 10. Think of it like setting up an empty potion bottle and then filling it with a potion. First, you prepare the container, and then you add the ingredients. Variable scope. All right, now let's talk about scope. Scope defines where your variables live and where they're accessible in your code. Global scope variables can be accessed anywhere in your code. On the other hand, imagine you have a magical book, but it can only be read in a specific room. This is like local scope variables created within a function are only accessible in that function. Knowing scope helps prevent errors and keeps your code neat and organized, just like a wizard keeping their spellbook sorted. Type conversion. Here you start with an original type. This is the data type that is declared initially. In this example, I'm assigning variable value with the value 1. Next up, conversion. In this step, we use the variable name and assign it a new value. In this example, the value is updated with the string example. And lastly, new type. After updating the value of the variable, we can observe the change of the value by printing the value of variable onto the console by writing the print statement in the code as such. Here's a magical trick. Sometimes you'll need to convert one data type to another. This is called type conversion, and it's like casting a spell to transform your data. For example, if you want to display a score as part of a message, you might turn a number, like 100, into a string by writing string. With a quick type conversion, you're all set. Now onto our third objective. Difference between constants and variables. Difference between constants and variables. Now, a quick but essential note. Not all variables are meant to change. Some are constant. Once you set them, they're locked, like a spell cast in stone. You declare these using the keyword const. For example, if you declare const pi equal to 314, pi won't change throughout your program. Constants are perfect for values that should stay fixed, like mathematical values or configuration settings. On to our last objective, good practices and common errors. Good practices and common errors. And finally, a few wizardly tips to keep your code error-free. Use meaningful variable names. It's tempting to name everything X or Y, but player score is way better. Be careful with spelling. Small typos can break your code. Double-check your names. And don't hard-code values. Use variables instead. This way, if things change, you only need to update it in one place. So there you have it, wizards. Today we've journeyed through the world of variables, from naming and types to constants and common pitfalls. Remember, variables are one of the most magical parts of coding. They allow you to store, manipulate, and reuse data across your projects, making your programs dynamic and engaging. Thanks for joining us on SyntaxWizards today. If you found this video helpful, give us a thumbs up, subscribe, and let us know in the comments what kind of coding magic do you want to explore next. Until next time, keep casting those coding spells and making magic with SyntaxWizards.